Okay, for this one, we're gonna use the rule that says radical n of A over radical n of B. So they have to have the same root for the radical. That's gonna be equal to the nth root of A over B. So basically you can combine them inside the radical with division as long as they have the same n. So this is going to become the cube root of 256 over n to the 10th over 2n squared. So two 56 divided by 2 is 128. And then n to the 10th divided by n squared is n to the 8th. So I actually can clean this up a little bit. And now I just need to figure out whether 128 has a perfect cube root and whether n to the 8th, how do we separate this into two pieces? So what I'm gonna do, it's often easier to do the prime factorization tree. So 128 divided by 2, that's 64. Divided by 2 is 32. That's 2 times 16. And that's 2 times 8. And that's 2 times 4 and 2 and 2. So 1, 2, 3, 4, 5, 6, 7. So what I'm going to do is put these over here. So 2, 2, 2, 2, 2, 2. And then the last one by itself over here. Because I'm going to need groups of 3. And then the n of the 8th, I need to break that up into something where this number is divisible by 3, and it doesn't matter what that one is. So the biggest thing that is less than 8 and divisible by 3 is 6. So I'm going to leave n to the 6 over here, and then n squared over here. Then that leaves me with, I can write this, I can multiply this out and then find the cube root of that. But just since I've done it this way already, let's leave it. So for every 2, for every 3, I take out one of them. So I'm taking out 2 2's. So for those 2 2's, when I multiply the 2 2's, I get a 4. N to the 6th, the cube root of that is n squared. Basically, 6 divided by 3 is 2. And then just leave the rest inside the cube root radical.